This is Lesson 9.3, Fundamental Counting Principle. The Shoe Warehouse sells sandals in different colors and styles. According to the table, how many colors of sandals are available? 1, 2, 3, 4, 5. 5 colors available. How many styles are available? 1, 2, 3. Find the product of the two numbers you found in exercises 1 and 2. Well, 5 times 3 is 15. Draw a tree diagram to find the number of different color and style combinations. How does the number of outcomes compare to the product you found above? Well, here's my 5 colors on the left: black, brown, tan, white, and red. I have my 3 styles: platforms, slides, and wedges. When I combine the color and the style, I have 3 black, 3 brown, 3 tan, 3 white, and 3 red, for a total of 15. So the two numbers are the same. Whether I multiply color times style or I make a tree diagram and list all the possible combinations, I end up with 15. In the activity above, you discovered that multiplication instead of a tree diagram can be used to find the number of possible outcomes in a sample space. This is called the fundamental counting principle. Multiply rather than diagram. The fundamental counting principle says if event M has M possible outcomes and event N has N possible outcomes, then event M followed by event N has M times N possible outcomes. Find the total number of outcomes when a coin is tossed and a number cube is rolled. Well, I have 2 possible outcomes for my coin, 6 possible outcomes for my cube. 6 times 2 is 12. If I draw a tree diagram down here to support that, I have heads and 1, heads and 2, heads and 3, heads and 4, heads and 5, heads and 6, and so on. Here's my 6 possible outcomes with heads, 6 possible outcomes with tails, for again, a total of 12. So multiplying or diagramming, same outcome, same number of items in my sample space or combinations. Find the total number of outcomes when choosing from bike helmets that come in 3 colors. So I have colors and styles. 3 colors, 2 styles. How many combinations? 6. The fundamental counting principle can be used to find the number of possible outcomes and solve probability problems in more complex problems when there are more than 2 events. The jean shop sells young men's jeans in different sizes, styles, and lengths, as shown in the table. Find the number of jeans available, then find the probability of selecting a 32 by 34 slim fit. Well, I have 5 sizes. I have 3 lengths. I have 3 styles. 5 times 3 times 3 is 45 possible combinations. There are 45 different types of jeans to choose from. Out of the 45 possible outcomes, only 1 is favorable. So remember, probability is favorable over possible. So my 32-34 slim has a probability of randomly being selected 1 in 45 times. If the jean shop added relaxed fit, so that means instead of 3 I have 4, find the number of available jeans. So 5 sizes, 3 lengths, 4 styles. 5 times 3 times 4 gives me 60 for a total instead of 45. 3630, again, can only occur 1 time. My 1 favorable out of my total of 60 possible outcomes gives me a probability of 1 in 60. Use the fundamental counting principle to find the total number of outcomes in each situation. Tossing a quarter, a dime, and a nickel. Well, a quarter, I have 2 possible outcomes, heads and tails. Dime, I have 2 possible outcomes, heads and tails. Nickel, I have 2 possible outcomes. 2 times 2 times 2 is 8 possible outcomes. Choosing a scrambled egg, sunny side, or poached egg with bacon or sausage and milk or juice. Well, let's see, I have eggs. How many styles of eggs? I have 3. How many ways can I choose the meat? I have 2. And my drink, I have 2 possible outcomes. So 3 times 2 times 2 gives me 12 possible combinations of breakfast. Choosing a number on a number cube and picking a marble from the bag at the right. Well, my number cube has 6 possible outcomes. I have 4 marbles. So I have 24 possible outcomes. Beth has 3 sweaters, 4 blouses, and 6 skirts that coordinate. Find the number of different outfits consisting of a sweater, blouse, and skirt that are possible. Then find the probability of selecting a particular sweater, blouse, skirt outfit. So sweaters is 3. Blouses is 4. Skirts is 6. So 3 times 4 times 6 is 72 possible combinations. The chances of randomly selecting one particular outfit then would be 1 in 72. The only vocabulary in this lesson is the fundamental counting principle, which uses multiplication of the number of ways each event in an experiment can occur to find the number of possible outcomes in a sample space, rather than making a tree diagram. At this point, you should quit the video, go to NICU at www.nicu.net, and take lesson quiz 9-3. Remember to log in using your student number. Your password is your student number followed by your last name. Thanks for watching.